Okay, so in this video I'm just basically going to talk about lengths of vectors and how do you find that length of a vector and stuff. Now, the length of a vector, the length of a vector will basically just be the distance from its initial point to the terminal point. That will just be the length of a vector, right? So now let's say probably we have like a unit cube here on this coordinate plane, and we want, let's say maybe we have vector OA, meaning that A, it's our terminal there. So now since this is like a unit since this is a unit cube, what will be the coordinates of A? So we can express A as like 1, 1, and 1. So that will be A, and now O is at the origin, so we'll have 0, 0, and 0. That's just basically the coordinates of the origin. So now we have vector OA. So this will just basically be the coordinates. My apologies on that. We have coordinates, and then our vector will be terminal minus initial. So 1 minus 0 is 1, and then 1 minus 0 is 1, and then also 1. Coordinate vector, right? Okay, so now what's the length of OA? What's the length of this vector? We're just going to denote that as so what you do when you're looking for the length of a vector, you're just going to take the square root and you square the components of that, the x component and the y component and the z component. You just square that, so you're basically going to have 1 square for the x component, and then you're going to have 1 square for y, and then you're going to have 1 square for z. So when you sum up all that, you're basically going to end up with root 3. That will basically be the length of this vector. Now here, what we're normally doing is we're basically just measuring the length of that vector from the origin, which is technically what most of the math is about. But now let's say probably we have vector v. If we have vector v and it's provided by 1, root 2, and 1, and now let's say we want to have a vector, a unit vector from this. If we want to have a unit vector of this, we have to first find the length of this vector. So you're just going to basically have the square root of 1 square plus the square root of 2, square that, and plus 1 square, all inside the square root. So you'll have 1 plus 2 plus 1, that's just going to be 4. The square root of 4 is 2. Now since this vector is given by this vector is only 2 units, so now we want to like have a unit vector from that. We're just going to divide every component here by the length of that vector. Let's say maybe our unit vector is it's u. So now we're just going to say 1 divided by this, it's just going to be half. And root 2 divided by 2, we cannot simplify root 2, so it's just going to be root 2 over 2. And then, sorry about this. And then 1 divided by 2, that's just going to basically be half. And then that will be a unit vector in the same direction as v. But what if now we're not looking for the unit vector? This is a unit vector. And now a unit vector, or in the same direction as v, in the same direction as v, But now a unit vector just means that vector with length 1, right? Keep that in mind. That will just be a vector of length 1, of 1 unit. So now, what if like they give you this vector and they say produce a vector with a length of 8? What do you do then? So if you want to produce a vector of length 8, let's call that vector w, and it has a length of 8. First, you find the length of the original vector, which we did, which is 2. And then, after that, since you're looking for a vector with length 8, and this vector is of unit 2, we first find the unit vector of that. And then, since now this vector here is of length of 1, we're basically going to multiply the unit vector with what? With 8, because now we're looking for a vector with length 8. So now, half multiplied by 8, that's going to be 4. And root 2 over 2 multiplied by 8, that's going to be 4 root 2. And then you'll have 4 there. So if you find the length of this, you're gonna have 8. So that's a vector. That's a vector with length 8. Length 8 in the same direction. In the same direction as v. So you see, basically it's simple, really. It's practically simple. Now here's an example. Try this one. Find a vector in the same direction as v, and it's of length half. Find the vector that's in the same direction with sv, and it's of length half. So now let's call that vector let's call that vector k. You can choose any letters you want. Now let's say first thing you find the length of v, which is 2 units, and then you can correct that to a unit vector. Now since we're looking for a vector with length half, we're basically gonna multiply every component by half. What's half multiplied by half? That's gonna be 1/4. And what's root 2/2 multiplied by half? That's gonna be root 2/4. Then half by half, that's gonna be 1/4. So this will be a vector of length half in the same direction as v. So you practically see that this is basically simple reading. It's basically simple reading. So like finding lengths of vectors is probably not that difficult, because like since I said this is a unit cube, you know that here you'll have your coordinates are 0, 0, 1. So that's how you'll give your coordinates x, y, z. And here you'll have 0, 1. You'll have 0, 1, and 0. And here you'll have 1, 0, 0. Now try to see if you can like label these other points on the cube. That's something you can try and see if you can like if you understand what's going on. And let's say this one it's B, right? And let's say let's call this one C. So we have A, B, and C. Now find the coordinates of B. Can you find the coordinates of B? Try that, for example. And then after you find the vector, the coordinates of B here, and let's call this one A, B, C. Okay, fine. Here's an example. After, okay, let me just give you the coordinates of B. Here you see that x is 1, and here z is also 1, but y is like y is technically 0 from this point, right? So now we're going to coordinate that x is 1, z is 1, and y is 0, because like you can see, y is 0, z is 1. Okay, not in vector form, but this is coordinates. Okay, so now you have this, you have practically A, B, and C. Now my question here is, show that AB is orthogonal to BC. Can you show that? Show that AB is orthogonal to BC. Now, how do you show that? The only way you can show that is if you prove that the dot product is 0. AB dot BC, that's just gonna be, well, let me just start like this. Let me write it officially. So you're gonna say BA dot BC. That will practically give you 0. Show that this is true. And if it's not true, that means that they're not orthogonal. Well, you know they're orthogonal because this is a cube. You already know that this angle will be 90 degrees from there. Now here, let's say that let's say we have vector A, which is denoted by x and 2. And we have vector B, which is denoted by 1, which is denoted by -1, and let's say this one is x squared, -1, 0, and 3. So we have these two vectors here. If we have these two vectors, where will they be orthogonal? And find the value of x such that these two vectors are orthogonal. So if these two vectors are orthogonal, that means that we're basically gonna have A dot B equals 0. Now you basically dot these two vectors. Now x squared multiplied by minus 1, that's just going to be minus x squared. And now 2 dot, this one is just going to basically be 0, right? Because it's 2 by 0, which is 0. And this one doesn't have a term in the first vector, so it's just going to be minus x squared equals 0. So that means that x equals 0. For these two vectors to be orthogonal, then x must be 0. There's no plus minus 0. 0 is 0, right? So that's where the two vectors will be orthogonal. Now, another way you can do this, so remember in the first video where I did an introduction, it's like I said, like a dot b is the same as a, the length of a, multiplied by the length of b, multiplied by cosine of the angle between the two vectors. Now, if the angle between if two vectors are orthogonal, that means that the angle between them is 90 degrees. And what's 90 degrees? It will give you 0. So that's why it's technically like that. So this formula comes in handy because now I showed you how you get the length of two vectors, right? So now let's say here you want to find the angle between where are the vectors? So okay, 1 root 2 1 and u. Okay, here, okay, find the angle between these two vectors, 1 root 2 1 and vector u, half root 2 over 2 and 1 over 2. Can you find the length between these two, the angle between these two vectors? So first you find the length of this one, which is 2 units. So vector v, the length of that will be 2 units, and the length of u is just basically going to be 1. Check. You can evaluate that. It's just going to be 1. And now that means that that means that v dot u, that's going to be length of v multiplied by the length of u multiplied by cosine the angle between them. Now let's dot the 2. 1 by half. 1 by half, it's half. Root 2 by root 2 over 2. Root 2 by root 2 is going to be 2. 2 divided by 2, it's 1. So you have plus 1. Now 1 by half, that's just going to be half. Plus half. This will be the same as 2 multiplied by 1, which is just 2. 2 cos theta. Now half plus half, that's 1. And you also have this 1 here. This will be equals to 2 cos theta. So now 1 by 1, that's 2. Then you have 2 equals 2 cos theta. So you end up with cos theta equals 1. So that means that the angle between them is 0 radians. 0 radians. Explain why the angle between them is 0 radians. Because here I technically said that these vectors are in the same direction. So they're basically, we have one vector on top of another. So that's why. So u lies somewhere on. So you basically, let's say this was vector v. Vector u will be somewhere along that v, because they're in the same direction. So that's why the angle between them is 0. So you basically see why the angle between them is 0. Now we're going to talk about projection of one vector on another. So this was just a glimpse of an idea of what's happening. And remember, you have a scalar projection and a vector projection. Thanks for watching. Don't forget to share and subscribe.